Hi there, what I'd like to do today is talk about specific groups found in the periodic table. In a previous video clip I said that elements are arranged in a periodic table, groups going down, periods going across, and elements found in a certain group are placed there because they've got a certain number of electrons found in the outer shell. Let's have a quick look now at group 1. These are called the alkali metals, and they go lithium, Li, sodium, potassium, rubidium and cesium. They're called the alkali metals because, would you believe this, they react with water to form alkalis, i.e. lithium or sodium or potassium all react with water to form hydroxides, alkalis. Lithium forms lithium hydroxide, sodium forms sodium hydroxide, NaOH, and potassium forms potassium hydroxide, and completing that equation they liberate hydrogen gas. If I added a piece of lithium to water, it practically explodes, and that proves therefore that going down the group they get more reactive. But why do they get more reactive? It's because of their electronic structure. It's to do with the number, it's to do with the closeness the electrons are attracted to the nucleus. Let's look at lithium. Lithium, Li atomic number 3, sodium atomic number 11. Its electronic configuration is 2,1. Sodium is 2,8,1. Metals form compounds by losing electrons. Let's look at the electronic configuration of lithium. There's the nucleus, which is positive. It contains neutrons and protons. And in the first electron shell, we've got 2 electrons. And in the outer shell, we've got 1. That electron is negatively charged, and you can see it's quite strongly attracted to the nucleus, plus and minus. And if I took the other example now, sodium is 2,8,1. See that, it's getting bigger. That's the nucleus, neutrons and protons, 2, 8, 1, 2, 3, 4, 5, 6, 7, 8, and the outer electron there. That is further away from the nucleus and will therefore be easier lost because the electrostatic force in that is small compared to that one. And that's why going down group 1, the alkali metals, as you go down that group, they get more reactive. What do you think about things like the melting point, the boiling point? It's common sense. As you go down that group, they get less and less, they're not so, the bonds and links get less and less and less, and therefore the melting points or boiling points would go down. Let's now look at the halogens. The halogens are group 7. Why are they found in group 7? Because there's 7 electrons in their outer shell, and they are fluorine, chlorine, bromine, iodine, astatine. They're found in group 7 because they've got 7 electrons in their outer shell. Let's look at a couple of these. Fluorine, chlorine. Fluorine 9, chlorine 17. Let's look at their electronic configurations next. Here is fluorine. Its structure is, electronic structure is 2, 7. There's a nucleus again. Is 2. And that is the nucleus. It's positive. And structure 2, 7, 1, 2, 3, 4, 5, 6, 7. It wants to gain electrons. So therefore, if you look at that, the forces between that, the outer electron and the positive nucleus, would be quite strong compared to chlorine, which is 287. Nucleus again, positive charge, 2. Hello, I can't count, and 8. And 7. So, the distance between that nucleus and the outer electron is further away. Therefore, it's less negative. Therefore, it's more likely not to attract more electrons because it's further from a nucleus. And that's why going down that group, the halogens, they get less reactive. In simple terms, fluorine is more electronegative than chlorine, etc. How do I know that? Well, if I took, and this is the next concept, is I'm talking about now a displacement reaction. I've said this, they go fluorine, chlorine, bromine, iodine, astatine, going down that group. If I took a solution of potassium bromide or potassium iodide and I bubble through chlorine gas, what happens is the chlorine displaces the bromine, chlorine displaces iodine because it's more reactive. If I draw that out in a different way, I've got potassium bromide and I've got potassium iodide. If I bubble through chlorine gas, the chlorine displaces bromine and I get bromine liberated. If I pass chlorine through potassium iodide, it liberates iodine because it's more reactive. In this case, it goes from a colourless solution to reddish brown because I got bromine being liberated, and in this case I get a purplish brownish deposit of iodine because the chlorine has liberated the iodine from the potassium iodide. The final group I want to talk about today is the inert gases, the noble gases. The noble, because they don't want anything at all to touch them, they're unreactive, and this is often called group O or group 8 because the outer shell is full. They are as follows: helium, neon, argon, krypton, xenon. Going down that group, they get larger, but the reactivity hardly changes because they're not reactive in the first place because the outer shell is full. Let's look at that in a bit more detail. 2 and 10. This is helium, this is neon. Helium's got a structure, there it is. There's the nucleus, neutrons and protons. That outer shell can only contain 2, so it's full, unreactive. Neon, 10, is 2, 8. There's the nucleus again. Nucleus, positive, 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. It's full, unreactive. It's not, does not want to gain or lose electrons. The physical state of those, the inert gases, it's because the electrostatic forces between those atoms is quite small. They're not positive, they're not negative. They don't want to gain or lose electrons. That's why the inert gases, they use in things like light bulbs, i.e. the hot metal inside the light bulb doesn't get hot, doesn't form any compounds. Air balloons, barrage balloons, neon signs. The inert or noble gases are unreactive because the most important thing you need to know is because the outer shell is full and they do not wish to lose or gain electrons. To summarize what I've said, metals want to lose electrons and form positive ions, and the non-metals wish to gain electrons and form ions. And the final thing I just want to say a little bit about that is lithium and sodium. If they lose electrons, -1e, -1e, they form positive ions. Sodium forms a positive ion. These positive ions are called cations, and if I took my non-metals, such as chlorine, oxygen, they want to gain electrons, 1 electron. Oxygen wants to lose 2 electrons, and it forms a chloride ion. Oxygen forms an oxide ion, and that would be minus, and that would be 2 minus. And these are called anions. I'll be talking about ions in a lot more detail in future clips, to be continued.